we can start out with like working with multiplying and dividing expressions. And we'll say that we have, starting off, see, we have multiplying polynomials. And just to sort of get us started off, okay, now we have with multiplying polynomials, okay, now there is, and there are various techniques that you can utilize, but we have what's referred to as the FOIL method. Okay, now sort of an acronym for first, outer, inner, and last. Okay, so we have just kind of a general case here. So you have a couple of two-term expressions. So you have the quantity of a plus b times that of c plus d. And in terms of multiplying out, so you have what's going to be multiplying the first terms from each of the expressions. So you have a times c. Then you have plus a times d. Then we have plus b times c. And we have plus b times d. Okay, so you have so you got your first terms, and then the terms most distant from each other. Okay, we regard those as outside. And then you have essentially the terms closest to each other. With b and c, those are the inside terms, and then we have the last terms from each of the expressions to multiply each other. So FOIL, first, outer, inner, and last. And if we take just as an example, say representing all of A and B as well as C and D. Okay, so we have the quantity of 3x plus 4 times that of x plus 7. Okay, so we have for A times C, you got your first terms, you have 3x and x. Then we have plus. Now the outside terms, you have 3x and 7. And then we have the inside terms, so you have 4 times x. And for the last terms, we have 4 times 7. Okay, so we have taken the product, so you have 3x times x. So you got 3, and x times x becomes x squared. So you have the first term becomes 3x squared. Outside term, we have 3x times 7, so this will be 21x. Inside term, we have 4 times x. And then we have 4 times 7, which would be 28. Okay, so got 3x squared, and this is the only x squared term that we have. Now for the middle two terms, we have 21x plus 4x. Now these are the same degree in x. So you have first order x terms, and we can combine these together. So you got 21x and 4x. So this will become 25x. And then we have 28 is the only standalone number. And so we have for the end result, okay, the product of 3x plus 4 and x plus 7. Okay, this will be 3x squared plus 25x plus 28. All right. Now let's say if we take as another case. you might see exponents outside of parentheses. And I'll give you a case here. And we'll say we have something like 4x minus 3y quantity squared. Okay. And what that 2 means is that if you rewrite this in terms of multiplying, you're looking at the number of appearances. This 2 will be the number of appearances of this 2-term expression when writing in terms of multiplying. So you have 4x minus 3y times itself. Okay. And like if I had 4x minus 3y raised to the third, it would be 4x minus 3y times itself times itself. So that 2 is going to be the number of appearances when you write exclusively in terms of multiplying. Okay, so we have taking the FOIL. So you got 4x times 4x. And we have with the outside terms, so you have 4x, and we have times negative 3y. And then we have for the inside terms, okay, so you have negative 3y times 4x. And then for the last terms, okay, we have a negative 3y times itself. Okay, so you got first, outer, inner, and last. So looking at multiplying, so you got 4x times 4x. 4 times 4 is 16. X times x becomes x squared. Now we have 4x times negative 3y. So you have a positive times a negative is a negative. So we have a minus 12xy. And guess what? We have negative 3y times 4x. And if I take the product and put the letters in alphabetical order, we'll come out with another negative 12xy. And for the last product, we have a negative 3y times a negative 3y. So this will be a positive 9y squared. And here we have, again, so you have 16x squared. That's the only x squared term this time around, just like 3x squared was the only x squared term in the previous example. Now we have like terms in first order x and y. And you got a negative 12xy and another negative 12xy. So we're going to have a negative 24xy. Then we have followed by the addition of 9y squared. Okay, and so we have another trinomial expression, or 3-term expression that will come about as the result. Okay, so again, we have 16x squared minus 24xy plus 9y squared. Okay, now in taking what we have, and let's say, I'll show you just another case here. And let's say that if we have something like 3x plus 4 quantity times the quantity of x minus 10. Okay, so if I were to FOIL out, again, the first terms, you have 3x and x. Yeah, plus the outside terms, you have 3x times negative 10. Yeah, with the inside terms, you have 4 times x. And we have with the last product, so we have 4 times negative 10. So we have here, okay, so 3x times x, again, we have 3x squared. 3x times negative 10, okay, so this would be a minus 30x. And then we have plus 4 times x. 4 times negative 10 is minus 40. Okay, so again we have 3x squared. Now for the x terms, okay, we have first order we have negative 30x plus 4x. So we have a negative 26x followed by minus 40. And I'll just mention something too. Now, some of you may have been exposed to what is referred to as the box method. Or the geometric foil, and what this refers to is if you have the quantity of a plus b times that of c plus d, and what you would have is kind of like, say, like a box, and it doesn't matter which you have as the row headings or the column headings. Let's say we have A and B as the column headings. So you have A plus B and C and plus D as the row headings. Okay, and for each of the sections, each of the blocks here, so you have A and C corresponding, multiplying together. So you have A times C, then you have plus A times D, and then we have completing the second column, we have B times C. Then we have for the last section, we have B times D. And if you string this on out, okay, so you have AC plus AD. So if you look at it visually going column by column, so you have AC plus AD plus BC plus B times D. All right. And just sort of taking, we'll just take the last case here. So if you got the quantity of 3x plus 4 times that of x minus 10 and just section. Okay, so we'll just let 3x and 4 be the column headings, and then x and negative 10 be the row headings. And looking at the correspondence, you have 3x times x, so you have 3x squared. Got 3x times negative 10 is negative 30x. Then we have plus 4x, and 4 times negative 10 is negative 40. And guess what? Through this particular lens, again, going column by column, so you have 3x squared minus 30x plus 4x minus 40. And guess what? We had the same terms carried out, and we still end up with the same result. Whereby we have 3x squared minus 26x minus 40. And, okay, now, in looking at what we have right now, tell you what, you could take either the regular foil or the geometric foil. Let's try out what we get for, let's say we have 3x minus 8z taken to the second power. So just for the next few minutes, okay, let's see what we get for the square of 3x minus 8z. Okay, so looking at trying out the square of 3x minus 8z, and again, you can go with either the traditional or the geometric FOIL approach. Okay, so the square of the quantity of 3x minus 8z, okay, that's going to be 3x minus 8z times itself. And I'll just take the geometric approach. Okay, so we have 3x minus 8z. Okay, which would be both the row and the column headings. Okay, so we have, so if you go with the traditional FOIL, you got 3x times 3x. So basically this is like this will be your first product. And 3x times 3x, this will be 9x squared. And the outside terms, you have 3x times negative 8z. And 3x times negative 8z, that will be a negative 24xz. And then we have with the inside term, you have negative 8z times 3x, so that's going to be another 24xz. And we have with the last product, you have negative 8z times negative 8z. Negative times a negative is going to be a positive. That's going to be 64z squared. Okay. So just looking at expanding, so you have 9x squared minus 24xz minus another 24xz. Then we have plus 64z squared. Okay, so we have 9x squared. And for the outside and the inside products, we have negative 48xz. And then we have plus 64z squared. And that will be the overall results here. Okay, so we're looking at multiplying expressions to get to one expression. But let's say that if we were to be heading in the other direction, instead of taking terms and multiplying to get to one expression, one might pose the question, well, if I had one particular expression, what are at least two terms that will multiply themselves into that one expression? And so instead of the FOIL, we're kind of taking the reverse. We're going to have what will be regarded as factoring polynomials. Okay, so you're kind of going in the other direction. Okay, say we have, if we're looking at expressions that will go into, let's say, I'll start out with one that's pretty general. Okay, so we have x squared plus 7x plus 10. Okay, so in terms of factoring, okay, now for the first term, that is x squared, and that times itself, which will give you x squared, is going to be x. So if I'm looking for two-term expressions, then we're going to x squared plus 7x plus 10. Let me mention, okay, now you got x squared, 7x, and 10. And the highest number that will go into all of like 1x squared, 7x, and 10 is just going to be 1. So there's no number to factor out. So we're just looking at variable expressions. So for x squared, this will factor out to x and x. Now in terms of how to fill in for the rest, okay, now we have the constant at the end to be at 10, and we're looking for a couple of numbers that will multiply into 10, and that will simultaneously add up to 7. And it doesn't matter what order you place the values, okay, and two numbers that will add up to 7 and at the same token multiply out to 10. Those numbers will be 2 and 5. And again, you could say x plus 5 times x plus 2, or as I have on display, you have x plus 2 times x plus 5. And let's say that if I have, say I have another second order expression, but I'm missing a first order x term. So we have x squared minus 64. And what that means is that since we have a missing x term, just to kind of give you a little bit of insight, now x squared minus 64 is a sample of what is referred to as a difference of squares. And the way you could look at sort of framing things is that we have a missing x term of first order, and you could just regard that as 0x. Alright, so we have x squared minus 64, and just formatting as a trinomial. Okay, since there's no x term, you just frame that as 0x. And factoring for x squared, this will go to x and x. Now for negative 64, okay, the only way for two terms to multiply into a negative is for one term to be positive and the other to be negative. Okay, and now if you notice before we had 2 times 5 is 10, 2 plus 5 is 7. Now we're looking at where we have a number times a number is equal to negative 64, but in terms of adding and subtracting, we have canceling each other. And guess what? That which will go into negative 64 will have the same weight in terms of adding and subtracting. So that missing number is going to be 8. Okay, so you have the result here. We have x plus 8 and x minus 8. So here we have a difference of squares. Now, let's say if we have something like x squared plus, let's say you have x squared plus 20x plus 100. So if I look at factoring, okay, so you have x squared, so this will go to x and x. And factors of 100, that will add up to 20. Guess what? 10 times 10 is 100. 10 plus 10 is 20. And if you notice, you had the binomial factors to be identical. And you have x plus 10 times x plus 10. And if I were to condense the expression, this is going to be x plus 10 raised to the second. Okay, and now for what we have, just in these examples, okay, so you have for x squared minus 64, that was the difference of squares. And just for x squared plus 20x plus 100, This particular item is referred to as a squared trinomial, meaning that you have a repeating binomial factor upon factorization. And let's say that just for the case and looking at factoring, and give you just a case here, and let's say that we have there's a middle term that is going to be subtracted. And we'll say that we have x squared minus 10x minus 24. Okay, so this is a factorable trinomial. Now x squared, this will factor out to x and x. And we have with negative 24, we'll have a plus factor and a minus factor. Now we're looking at two terms that will multiply into negative 24, and that will at the same time add or subtract to negative 10. So more weight is going to be given to the subtraction than to the addition. Okay, so you have a plus 2. Now 2 will go into negative 24, negative 12 times. And so we have the resulting factors. Then we have the quantity of x plus 2 times that of x minus 12. Okay. And tell you what, just for the next few moments, okay. And we'll say that we have here trifactoring, and we'll say that we have let's say have x squared minus 36. And also in terms of factoring, x squared minus 12x plus 36. And then we'll be looking into some special cases regarding factors. So let's see what factors we get for these two expressions. Okay, for what we have for these two items. Now the first one we have the missing x term. So you could think of this difference, x squared minus 36, as x squared plus 0x minus 36. And we have a difference of squares signaling that we're going to have the same constant added and subtracted. Now for x squared, okay, this will go to x and x. Now as for negative 36, now 36 is a perfect square number, and negative 36 would factor out to positive and negative 6. So the factors of x squared minus 36 would be x plus 6, as well as x minus 6. Now, for what we have in the second case, now we have x squared minus 12x plus 36. Now again, a bit of history repeating. We have x squared, which will go to x and x. And this time for factors of positive 36, whose sum will be on the negative side at minus 12, and we're going to have negative factors for both of these. So numbers that will go into positive 36 and will add together at negative 12. Those are going to be identical at negative 6. So x squared minus 12x plus 36, this will go to x minus 6 times itself. And since we have repetition of this factor, that can be reduced to, or the expression can be condensed to x minus 6 raised to the second. Now, in the case of factoring, okay, say if the leading term has a coefficient that is greater than 1. Okay, say if, instead of having something like x squared, if you have like 2x squared, 10x squared, and let's say that the factoring is not quite so automatic. Okay, now we have what will be referred to as factoring by grouping. show you what I mean by this. Okay, so for factoring by grouping, let's say if you have an expression and we have 3x squared plus 19x plus 20. Now in terms of factoring by grouping, okay, what you're going to do in the case of factoring by grouping, okay, what you're going to look at will be the first and the last numbers. First number we have at 3, last we have at 20, and we're going to multiply these together. Okay, so you have 3 times 20, okay, is equal to 60. Okay, so we're involving the first and the last numbers. Now we're going to involve the number 19. And to get to 19, what we're going to do is that we're going to take what we have in the product with the number 60 and try to determine factors of 60 that will add up to 19. Okay. And just like what we had moments ago, it had 3 times 20 was at 60. However, those numbers are going to add up to 23. But we want numbers that will go into 60 and that will add up to 19. So 3 and 20 will not do it. But if I go with 4, 4 will go into 60 15 times. And 4 times 15 is 60. 4 plus 15 is going to be 19. So that will check out. And so in taking what we have with this particular trinomial, okay, so we're going to involve 4 and 15. So what do we do with 4 and 15? We're going to transport these numbers over, and we're going to split the middle term, which has the coefficient 19, and we'll split this up into terms that will have 4 and 15 as coefficients. So what's going to happen here? We have 3x squared, and upon splitting 19x, we're going to have, and it doesn't really matter what order you place these terms. So you have plus 4x plus 15x and we have plus 20. And then where the grouping comes in, okay, so you got 2 terms at the front, 2 terms at the end, and the addition between 4x and 15x, okay, that would be the operation in the middle. So we group together the first 2 terms. So you got 3x squared plus 4x, and once again you have addition in the middle. And then grouping together the last 2 terms, okay, so you have 15x plus 20. And after the grouping, now we're going to draw out what is regarded as the greatest common factor of each set. Now for 3x squared and 4x, now the highest term that will go into both 3x squared and 4x, that is limited to x. And x will go into 3x squared 3x times, and x will go into 4x 4 times. And we'll bring down the addition. Now for 15x and 20, okay, now the highest factor that will go into both 15x and 20, okay, we're not going to have a variable term since 20 is a number and 20 does not have the x. So we had the highest number that will go into both 15 and 20. Okay, that is going to be at 5. And guess what? 5 will go into 15x 3x times. And 5 will go into 20 4 times. And guess what? For the resulting factors, if you notice, you have 3x plus 4 is going to repeat. So that which repeats is going to be one factor. And the terms on the outside, as well as the operation, we have x and plus 5. And guess what? The other factor, we're going to cluster together, so you have x plus 5. And you can check 3x times x is 3x squared. 3x times 5 is 15x. And we've got 4 times x is 4x. 15x plus 4x is 19x. And 4 times 5 ends up at 20. And let's say that if you have another scenario, and let's say that if we have something like, and there's a bit of, if you're looking at this for the first time, there is a bit of muscle flexing that is involved. Now let's say we have something like 10x squared plus 23x plus 6. Okay, so just initiating the process. Just like what was done earlier, you're going to multiply the first and the last numbers. So you got 10 times 6. So you have 10 times 6 is 60. Again, we're looking at factors of 60. You have that bit of history to repeat. And you're looking at where the sum is going to be 23. Okay, now we just dealt with 10 and 6. However, 10 and 6 will add up to 16. And we're looking at a combination that will add up to 23. So that will be 20 and 3. 20 times 3 is 60. 20 plus 3 comes out to 23. And since this is the right combination, again, the 20 and the 3 will form individual x terms with their respective coefficients upon splitting the middle term in the original trinomial. We got 20x plus 3x plus 6. And as we enter the phase of grouping, so we got 10x squared plus 20x and we have addition in the middle. And we have the quantity of 3x plus 6. And where the factoring by grouping is going to come in. So for 10x squared plus 20x, highest number going to both 10 and 20 is going to be 10. And both of these have an x in them. So the greatest common factor between the first two terms will be at 10x. 10x into 10x squared is going to be x. 10x into 20x is going to be at 2. And for 3x plus 6, okay, greatest common factor, okay, that's just going to be a number, and that's going to be at 3. And guess what? 3 into 3x plus 6 is going to be x plus 2. Notice before we had shared factor between the groupings, and we have that bit of history to repeat. And this time, that which is shared is going to be the binomial x plus 2. And the other factor, this will come from the outside terms in operation, so that's going to be 10x plus 3. And again, you can check your result. X times 10x is 10x squared. You got x times 3 is 3x. 2 times 10x is 20x. And 3x plus 20x makes 23x. And 2 times 3 is going to be at 6. And so those are going to be your two factors for this overall expression. All right. And all right. Any questions? Okay. let me mention, okay. Again, if you're looking at, if you haven't seen this in some time, or you're looking at it for the first time all over again, so to speak, again, it is a bit of like flexing muscles, like just kind of getting back into into the training aspect of things. And I will try not to send out too many announcements or emails, but I'm going to send some things like in terms of getting started with Alex. I'm going to have some videos available, and just kind of like the process of getting uh, the toes into the cold swimming pool water. Okay, and but anyway, just some items to go ahead and look into, and not to turn in, but just kind of becoming acquainted, if not reacquainted, with factoring and multiplying and working with polynomials overall from your textbook. Go ahead and be looking at on page 41, numbers 77, 87, 91, 94. We have number 102 and also 106. And some of these will be fairly short answer items, and there will be some others in the mix that will get to be quite a bit analytical. And we will discuss those for next time.